For the last 50 years, the titanium aerostructure market has been dominated by the forging industry, and we're developing a process which will not only be economically viable in comparison to the price, but also a more sustainable way of making those components for the major primes. The driver for our technology, PM-HIP, is to drive down lead time, drive down cost, and drive down machining of the component. So let me give you an example. If Airbus was to give us a model of a component, we can design the capsule and manufacture it within 4 working weeks. We can fill that with titanium powder, we can outgas that titanium powder, we can HIP that component, and in under 8 weeks we can have a solid component ready for machining.
These were really exciting projects from NATEP's perspective because they really focused on the titanium aerostructures industry and really competing and disrupting the traditional forging technologies that are incumbent in this industry. It's bringing in technologies that are typically elsewhere in terms of Russia, the Far East and America, and bringing them into technologies and industries that are possible within the domestic market.
This is the polystyrene pattern that we've used for the process. This is an example of the part that we actually produced on the project. And as you can see, when you look at the complexity of it, because we're producing a cast part, we're able to produce significant deep pockets inside the component, saving weight and saving machining allowance as we then go into the final machining stages. It's a very complex gating system that we've had to produce, developing and working with the foundries to produce it, and it gives you an idea of the scale and size of the components that we're now able to produce.
We're stood outside our in-house lab, which is really important for us to determine the powder characteristics and good quality control. And what we're really using this laboratory for is to determine things like the powder shape distribution and size distribution, and we do that via sieve analysis and riffling analysis. And we're also looking for things like surface morphology, so whether something is particularly circular or angular in shape. And we're also very keen on maintaining good cleanliness, so the glove box, which everything is done, is a slight positive inert atmospheric pressure, so we can make sure that the powder remains nice and clean. When the capsule has been determined as leak tight, it gets moved into our vibration and filling room. This is where the powder is fed under gravity through a hopper into the internal capsule volume. And by promoting the filling with a little bit of vibration, we get an even powder head, and we make sure that the capsule has a sufficient material for densification.
Once we have the titanium powder inside the capsule at the correct weight, the next stage is to create a gas-tight capsule. And how we do that is we connect it to our vacuum system, and we also put it in an oven, and we actually have to bake it out. There is moisture on powders, and we have to drive that moisture off the powder, but more importantly, we have to create a gas-tight capsule. Once we've reached the right vacuum levels, our operators will come along and they'll do what they call hot crimping. And they will heat up these fill stems and mechanically crimp and seal the fill stems, and we now have a gas-tight capsule ready for the next stage called HIP. With our technology, everything is done under 60 decibels. So for a working environment, it's a very clean, high-tech environment compared to a heavy industrial situation such as forgings or castings where they're pouring hot metals.
Really, this technology is a key one for NATEP in terms of a success story. We saw this technology and the companies develop from very small entities to begin with. Proxima was 3 people at the beginning of the NATEP project, to growth and realization of a key disruptive technology. And we're seeing the status now where they are now moving into much larger premises. They are winning contracts with major defense and prime organizations in the aerospace industry. They are reaching fit to fly criteria with very key primes. They are really a key example of the success story possible with NATEP.
I think we're in a really good position now, based off what we've done with NATEP, to springboard into industry and be a real disruptive technology.
In terms of this technology, it really is a fundamental change in terms of pace for development and R&D within the industry. It allows us to move from a typical forging that is months and months of tooling manufacturing into something that can develop into an actual product within 8 to 12 weeks. We're really looking at being able to revolutionise how quickly and how cost effectively our primes can actually do development within a domestic supply chain. And that has quite obviously led to very good engagement from new customers. They have now got customers lining up in the years to come, and we look forward to seeing the success of Proxima as they move forward.